Right, using formulas in geometry. Today, we're going to get down to the essence of geometry. We're going to actually be using some shapes here. Okay, I know we've been talking about the basics lately. We've been talking about angles. We've been talking about segments. We've been talking about lines. But today we're going to talk about using the actual formulas in geometry. How does this work? Well, let's see. Some of the formulas that we're going to use may be familiar to you. This is a pretty short lesson. It should be about 10 minutes. Okay, so we're going to use some of the formulas in geometry and just review them, see how they work. Section 1.5. A little bit of vocabulary. It's very important for you to understand this vocabulary before we are able to go on. We have to understand the basics before we can do anything. Perimeter of a plane figure is the sum of the side length of the figure. Okay, the distance around. That's another way that I'm going to put it. If you're out there taking notes, you can just shorthand it, because the distance around is going to tell us how far would it take to get around. So if I was going to walk around this figure, how long would it be? Okay? At the bottom, area. Area of a plane figure is the number of non-overlapping square units of a given size that exactly cover the figure. How much area does it cover? How many squares does it cover? Now, those squares can be different sizes, but basically what we're saying is how many squares does it cover? And once again, what we're talking about is of a certain size. How many squares does it cover of a certain size? Okay? Now, they could be inch-wide squares, they could be centimeter-wide squares, but at the end of the time, how many square units does it cover? Okay? A little bit of background vocabulary there. Now, for example, I think the concept of having square units can be foreign to some of us. And we don't want that to be foreign to us because we want it to be something that we're comfortable with. So here's a little illustration to kind of show us how this works. Square units. What I would say is, I might ask a question like this. How many square units is this? Okay? And obviously you're going to count them and you're going to go, duh, there's 10. But really, that's the underlying question. Here's how it would be framed. It's the same question. How many square units are there? Well, duh, we count them. But we have to come up with an easier way to try to find this out because we don't want to always draw the square units on there. So what we would say is this. There are 2 units on this side. And there are 5 units on this side. Okay? And so an easy way, if we didn't have those lines in there dividing them, we would just say 2 times 5 is 10 square units. 10 square units. Because the units are squares. Okay? The units are squares. There are 10 of them. Okay? Now, perimeter and area formulas. This is going to look familiar. This is a picture out of your textbook. Okay? A picture out of your textbook. Not very difficult to recognize the pattern here. We've been taking these formulas for a long time. It's a little bit skewed, but let's look at a rectangle. A rectangle, and these P's are going to be perimeter, and area is going to be in the A. Okay? So here's what's happening. The perimeter of a rectangle. If I went ahead and filled this in, this is going to be W over here, and this is also going to be L up here. How do I know? These tick marks tell me. Notice, 2 tick marks on the top and bottom, 1 tick mark on each of the sides. So the perimeter is going to be width plus length, or 2 times W plus 2 times L. Okay? You see how this works? It's an addition problem. So the area then is going to be one of the sides times one of the sides, width times length, length times width. Okay, that's probably commonly how you've seen it. A square. Notice, even though it's skewed, I have tick marks. So really what this means is this. It means that I have, okay, I have S on all of the sides. All of these sides are S length. So the perimeter is going to be S plus S plus S plus S, or 4 times S, because all the sides are the same. Even though they don't look it, they're marked it. Okay? And the area is going to be S times S, which is equal to S squared. Notice, the length and the width are the same. So it's still length times width, but they just happen to be the same, so it's going to be side squared. Okay? Now, for the triangle, a little bit trickier here. But because we know that we have the 3 sides, the perimeter is going to be A plus B plus C. Pretty simple. The perimeter is A plus B plus C. The area for the height, however, is going to be a formula that you've probably seen before, but here's a review. 1/2 the base times the height. B, of course, being the base here. That's B. All right? So 1/2 the base times the height. Or some of you will commonly know it as base times height divided by 2. Dividing by 2 is the same as multiplying by 1/2. Okay? So those are the basic formulas that we're going to be working with here. Now, in this part, very important, once again, this vocabulary. The base can be any side of a triangle. It's very important that you remember this. Can be any side of the triangle. It depends on how it is rotated. It depends on the triangle. Because as you see below here, we have 3 triangles. And those 3 triangles have very different configurations. But watch what I'm going to do. Down here, okay, depends on the triangle. Because down here at the bottom, we have 3 separate triangles. It depends on how you draw the height. Because the height, H, is a segment from a vertex. A vertex, meaning a corner, that forms a right angle with a line contained in the base. The height may be a side, or in the middle, or on the exterior of the triangle. Okay? Let me illustrate this for you. This first one, it is a right triangle. And so this is perhaps the easiest one because the base is the bottom. Notice. The height may be a side, because in this case, the height is the side, because it forms this 90-degree angle right here. Okay? I want you to see this. I want you to see this. I've got a 90-degree angle here. So the base here and the height form a 90-degree angle. See how that happens? Now, in number 2, I'm going to use a different color. I don't have a 90-degree angle. This is not a 90-degree triangle. This is an obtuse triangle. Okay? This is going to be on the exterior of the triangle, because watch what happens. When I try to draw my 90-degree angle, I can't put it inside, but what I need to do is I need to drop down a line that comes like this and extend the base like this. Now I have my 90-degree angle right here. You see how that works? Okay, because the triangle is still this high. It's still that high. But the height is a measurement that's on the outside. Because notice, this side right here, it's longer than the height. We don't want that. That throws us off. So then the base is going to be just this piece down here. This is the base. So the base doesn't extend out, but that line just extends out from the base. That's the base and the height. Okay? The next one. I'm going to pick a different color. I'm going crazy today. It's wild. It's madness. I'm a madman. Okay? It may be in the middle. in the middle. Our height is going to be right here, because that's where I can draw my 90-degree angle. See? All right? None of those angles are 90 degrees, but that one just happens to be. And so my height is this right here. And my base is this whole thing down here. Okay? You see how I did that? So the height is telling us where we can find the base. Because the base, notice, the base always 90-degree angles. Okay? Always 90-degree angles. Now, finding perimeter and area. Here's some practice for you. If you want to go ahead and pause it, see if you can do these, that would be amazing. If not, I'm going to roll through them and you can check your answers. I like to draw pictures, so I'm going to draw a picture for this one. Nice black rectangle here. So I know that these sides have a relationship like this, and what I'm going to do is I'm going to say the length is 17, so this is 17 up here, this is 17 down here, label it with centimeters, okay? I'm going to label the widths with 5 centimeters because it's telling me that, 5 centimeters, and then it's just set them up, knocking them down. Here we go. Perimeter, add them all up, 17 plus 17 plus 5 plus 5. Well, 5 plus 5 is 10, so I've got 34 plus 10 is equal to 44. And my units, I have to remember my units. 44 centimeters. Okay? Area. The area is, recall, length times width. Just one of them. 17 times 5 is equal to 85 centimeters. Now, remember, it's in squares, square units, okay? So if I were to, I'd have to draw like bunch of little squares in here like that. There'd be 85 of them because I'd get 17 across, okay? A triangle in which A, B, and C, and H are the following. Here's my triangle. We're going with black again because we're staying here. Height is 6. Doesn't tell me where it is. Doesn't matter. I'm just putting it here. A, B, 6. I'm going to put B on the bottom because that's the base, you know? So the height is 6. Now, what do I do if my height I've already put in there and I run out of room for the rest of my measurements? Well, I must be dealing with a triangle that has a little bit different configuration. Let's look at it. If I have A, B, C, and H, what if I draw one like this? See what it looks like? Looks like this one here. Okay, we're going to draw that one. So I'm going to put my height in here. Drop it down like this. It's going to be 6. My base is going to be x plus 1. My C is going to be 4x. And my A is going to be 8. See how I did that? Perimeter is 8 plus 4x plus x plus 1. Look, guys and girls, it doesn't matter if there's x's in there. It really doesn't. Because if they're x's, we're saying they don't have a value that we know of yet. But we know that they have a value. And so when I add these up, I simply combine like terms. I've got 9 plus 5x equals 5x plus 9. What are my units on it? We don't know. 5x plus 9 is my perimeter. Let's go area right here, coming at you. We're going to write in white. Area, we know that it's 1/2 base times height. Let's look at this. The base is x plus 1, so I've got 1/2 times x plus 1 times the height, which is 6. Watch what I do here. I'm going to use a property of algebra to rearrange these things. 1/2 times 6. Having a little trouble here. Jumping around. 1/2 times 6 times what's left over? X plus 1. I have to write it in black. X plus 1. Okay? So I've got 3 times x plus 1. I use the distributive property to do x times 3 is 3x plus 1 times 3, which is 3. This is my area. Okay? That's my area. All right. Now, square with s equals 5. What is this talking about? I'm talking about a square. This side's 3.5. But all of them are the same. Notice how I sync that in time with my talking. So the perimeter is 4 times 3.5. When I do 4 times 3.5, I've got 12 plus 2 is 14 inches. And if I do the area, I know that I've got 3.5 times 3.5. It's okay to use a calculator there. So I'm going to go with 12.25 inches. And that's squared because it's in square units. Okay? So you see what we're working with here. It's a plug and chug kind of a thing. Plug and chug formula. Vocabulary. Talking about circles. We've hit the major plane shapes. We're talking about circles now. Okay? Our next one with the circles. We've got diameter is a segment that passes through the center of the circle and whose endpoints are on the circle. Look at this, guys. Look at where it ends. Edge of the circle. Edge to edge. Right here. Okay? Edge to edge. Right like that. Radius. It goes from the center. It's a segment because it stops. It goes to the edge of the circle and it's done. The circumference. If we were going to walk around a circle, this would be our distance around. Watch what I'm doing, guys. Right here. I'm all the way around. This is in a circle. It's a little bit skewed because it's a picture from your textbook, but it's a circle. It's all the way around. Okay? But the circumference is also a segment. Guys, look. Look how it stretches out. Look at it. It's all the way around, and it can be stretched out into a length. It's a single length. Okay? And so that's also a segment. So these are distances that we can measure. How do we measure them? Right here. Boom. Circumference. Is pi times diameter. Okay? It can also be equal to 2 times pi times the radius. But notice, 2 times the radius is equal to the diameter because the diameter goes all the way across. The radius only goes halfway across. See how I did that? Okay? Area, pi times radius squared. We've left one question unanswered. What's the question? Who's this guy? This is the Greek letter pi. Okay? It's a Greek letter. How do we derive pi? Pi comes from the ratio. Yes, you should write this down. The ratio of a circle's circumference to diameter. For example, here we go. It's going to be like this. Circumference That's what we're talking about. If you divide the circumference by the diameter, you're going to get pi every time. It's for every circle. I'm even going to write it across here, so you might have to rewind. This is for every circle. Every circle. That's why it's a beautiful thing. When they figured this out, it was revolutionary. So what do we use for pi? I'm going to go pi is almost or just about equal to 22 over 7 or 3.14. About equal to. Not exactly equal to, because pi goes on forever. The digits of pi go on forever. Okay, but that's how we're dealing with this. Okay, next part, last part. We're going to find the area and circumference of a circle. But here's what I'm going to do first, guys, because I'm being a smart student here. Circumference is pi times diameter. Okay, area, pi times radius squared. You see how I did that? I wrote the formulas up there. And so when I get into this situation and I'm saying this is 3 centimeters here, and they've already given me radius 14 meters, I'm plugging and chugging, guys. That's what I'm doing right here. All right, let me write this on here. A is equal to pi times radius squared is equal to pi times 3 squared is equal to 9 pi. I'm leaving it here, guys, because pi is not rational. Pi goes on forever. But if you're one of those people that needs decimals, it's about equal to 28.27. And what are my units? Centimeters squared. All right? 9 pi, centimeters squared. It's a good answer. If you want to, go ahead and try B on your own. Go ahead and pause if you need to. If not, we're rolling right through. You can check your answer later. So, area, once again, equal to 14 meters times what? 14 meters times pi. Pi times radius squared is equal to 196 pi meters squared. The perimeter is going to be the circumference. Notice, see how I did that? We haven't necessarily talked about this because I even skipped it in the first example, but we'll go back. But look at what happens. The perimeter, the distance around, is called the circumference for a circle. It's got a different name, but it's the same thing. We're going pi times diameter. Well, what's the diameter? If the radius is 14, the diameter equals 28 because it's twice. Okay? So, pi times diameter is 28 times pi. Okay? I'm not satisfied. If you're a decimal person, you're not satisfied. Once again, this is units meters. I'm going to go here. I'm going to go 87.96 meters around. Okay? Up here for area, if you're a decimal kind of a person, you're going to have to figure it out on your own. But I'll help you out here. 196. I'm not a fan of the decimal because it's not exact. I like exact because now I've got to round it. It's 615.75 meters squared, but that's rounded. Okay, I like this better. This is my ideal answer. All right, ideally that's what I've got. Let's go back over here. Perimeter is equal to pi times diameter. Well, if this is 3, then the diameter is equal to 6 centimeters. So that's going to be 6 times pi, which is going to give me 18 something, guys. 18.85. And that's going to be centimeters. Okay? That's the basic rundown. We're out of time. But this should be sort of a review. Come into class tomorrow, prepared to go. Thanks for watching.